Acids and bases are called weak because they do not dissociate completely and their conjugate bases or acids undergo the reverse reaction to give you the original product. But what if you only add the conjugate base or acid without adding the acid or base in the first place? What am I talking about? For example, look at sodium ethanoate. Salts dissociate completely in water to give you cations and anions. In this case, the anion is ethanoate, which is the conjugate base of ethanoic acid. And if you recall the reaction of ethanoate with water, it produces hydroxide ions. So does that mean if I dissociate a sodium ethanoate in water, I get a basic solution? Yes, not all salts form neutral solutions, see? Because the ions can react with water to form either hydronium or hydroxide ions. And we can classify salts into 5 different groups in this table. We want to know the type of solution that it forms with water, whether it's acidic, basic, or neutral. And you can always look at the Ka or Kb of reactions, if any, producing the ions that affect pH. But for ease of reference, we just put them here, just as your own textbooks and notes have probably done so. First, salts that are formed from strong acids and strong alkalis are neutral. That means for salts like NaCl formed from hydrochloric acid and sodium hydroxide, they will react with each other in water to give a solution that has negligible impact on pH, assuming equal molar ratios, of course. Second, salts that are formed from weak acids and strong alkalis are alkaline. The term alkaline is more specific because alkali is a soluble base. You can think of this as if the salt retains some of its strong alkaline properties, which to some extent is true. For example, the reaction of sodium hydroxide with ethanoic acid will produce sodium ethanoate. The ethanoate anion will react with water to produce hydroxide. pH of the solution then becomes greater than 7. The solution is alkaline or basic. Third, salts that are formed from strong acids and weak alkalis are acidic. For example, HCl and ammonia, which forms ammonium chloride in water. The ammonium ion can react with water to form hydronium ions. Again, you can think of this as if the salt retains some of the strong acidic properties. The pH of the solution then becomes less than 7. The solution is acidic. Fourth, salts that are formed from weak acids and weak bases are not really here or there or anywhere because they are both weak. And it boils down to comparing which one exactly is weaker than the other. For example, in the case of ethanoic acid, reacting with ammonia to give you ammonium ethanoate, both are relatively strong conjugate bases and acids, and they react with water to form hydroxide and hydronium. So we need to compare the Ka of ammonium and the Kb of ethanoate. The Ka of ammonium happens to be 5.6 times 10 to the power of negative 10, while the Kb of ethanoate is 5.5 times 10 to the power of negative 10. Shucks, that's pretty close. But since Ka is slightly higher than Kb, the solution will be mildly acidic. You can reason it out with the concepts from the earlier checkpoints yourself. Finally, salts that contain cations with high polarizing powers are acidic. This is a concept drawn from inorganic chemistry, but applies here as well. What is polarizing power? Let's take Al3+ ion for example. It has a pretty high magnitude of charge 3+. That's pretty high. It is also very small in size. It is in period 3 of the periodic table. This means that it has more charge packed into a tinier volume, which gives it a higher charge density. Think about a large but weak magnet versus a small but powerful magnet, like amazing neodymium magnets. You kind of get the idea that a small but strong charge carrier is going to cause a lot of trouble. It so happens that when these ions dissolve in solution, water molecules having a certain degree of charge separation as the oxygen atom in it is more electronegative, is attracted to the ions and it forms a complex like this one. However, the charge density of Al3+ is so strong that it can transfer to H atom of water, which causes it to be released from water, forming hydrogen or hydronium ions. And you know what that means, of course, the solution becomes acidic. This is something that happens only for ions with high charge density. The pH of solutions of Mg2+ and Al3+ are generally 6.5 and 3.5 because of this effect. Na+ does not have enough charge density. That's why it does not affect the pH of the solution. So these are the different types of salts and different ways that they affect the pH of the solution when they are dissolved in water.